Page 85, we're looking at volume. Find the volume of each figure. Use 3.14 for pi and round your answer to the nearest tenth if necessary. So technically, if you don't round to the nearest tenth, you've missed the question. So be careful with rounding. All right, this first one is a cylinder, and the formula for volume of a cylinder is pi r squared h. Pi times radius squared times h. Centimeters are throughout, that's a good thing. So we have 3 to the second power, that's going to be 9. So volume is pi times 63. And that is 197.82. But it told us to round to the tenth. So technically we have to go a step further. 197.8 cubic centimeters is the final answer. We must follow the directions. And I'm going to highlight these so that I always go back and check just to be sure I'm not giving you the wrong answer. So this makes it easier for me to check. All right, number 2 is a rectangular prism or a rectangular solid. And the volume will be length times width times height. And they're all in inches, so that's a good thing. The long side is 8, 6 wide, 2 high. So if you multiply all of that, 6 times 8 times 2 is 96 cubic inches. No need to round that one. It is a straight up even answer. Number 3, we have a cube where we have S, 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 and each of those is 3 meters. So the volume of a cube is edge to the third power. You can also use length times width times height. Will work just fine. So 3 meters to the third power. Remember, that's not 3 times 3. It's 3 times 3 times 3, which is actually 27 cubic meters. Here's a cylinder. It's lying on its side, but that doesn't matter. The volume formula is still going to work. Pi r squared times height. So pi times radius squared times height, or pi times 9 times height, and that is 90 times pi, is 282.6. That's already to the 10th place, and that will be final answer. Number 5, be careful, is a cylinder. The reason I say to be careful is because they're showing me diameter. I need to know radius. So this would be 7 centimeters. This would be 7 centimeters. All right, so the formula is volume equals pi r squared times height, or pi times 7 squared times 4 centimeters height. 7 sevens are 49, and then we have the height. So 3.14 times 49 times 4 is 615.44, but we have to round. So it is approximately 615.4 centimeters cube. And number 6, we have a rectangular prism. So volume is length times width times height. Volume is 20 times 10 times 1.5 feet. And so I'm going to do 20 times 10 times 1.5 is 300 cubic feet. And I think I forgot to color these, so I'll go back when we're done. All right, number 7. How much greater is the volume of the first box than the volume of the second box? So I can look at this and tell that the first box is bigger. I can also tell that my units are all the same, thankfully. So let's do 2 volumes and see what we get. This one is length, width, and height, and then this one is going to be the edge to the third power. So length is 8, width is 5, and height is 4. So volume, I believe, is 160. Let me check it because I don't trust myself. And that's 160 feet cube. Then this one, we have one edge is 5, and we're going to raise that to the third power. So 5 times 5 times 5 is 125 cubic feet. How much greater? That word means subtraction. So 160 minus 125 is 35 feet cubed. And that is the final answer. Number 8. A plan for a concrete wall calls for it to be 1/2 foot thick, 6 feet high, and 45 feet long. So we do have like units: foot, feet, feet. What is the volume of the wall in cubic feet? So that's going to be length times width times height, or 48, 6, and 1/2. So 48 times 6 times 0.5 is 144 cubic feet. So that's the answer to part A. Part B says that concrete is sold in cubic yards. 1 cubic yard equals 27 cubic feet. This is feeling like a ratio proportion problem. How many cubic yards of concrete are needed to build this wall? You can do it different ways, but I'm going to set it up using my proportion. That 1 cubic yard is equal to 27 cubic feet. And then I'm going to bring in this answer, 144 cubic feet, and solve the proportion. So I do 1 times 144, that's 144, divided by 27 is 5.3 repeating, or 5 1/3 cubic yards. And the fraction 1/3 is fine as well. It didn't say to round, so I would leave it as 5.3 repeating or use the fraction 1/3, either one. A cylindrical tank has a height of 20 feet and a diameter of 16 feet. What is the volume of the fuel tank in cubic feet? So we have volume equals pi r squared h, because this is a cylinder. So volume is pi times the radius squared. I know the 20 is the height. If diameter is 16, radius is half that, or 8. So volume is pi times 64 times 20. And volume is approximately 3.14 times 64 times 20 equals 4,019.2 cubic feet. And finally, on this page, the illustration shows a cylindrical can and a rectangular box. If the can in the drawing is full, is it possible to pour the contents into the box without the box overflowing? So this is a yes/no question. So if this can is full of paint and it's full, we want to pour it into this tray. Will it fit or will it overflow? Is what we're looking at. So I'm going to take the volume of the can that we know to be full, and it's a cylinder, so this is the formula. So we have pi times the radius squared times the height. It's all inches. That's important. Look at all of this. They have to match or you're in trouble. So be careful there. So the volume is pi times 25 times 12. So pi got 942, but that doesn't feel right. Let me try it again. 3.14 times 25 times 12. Okay, that's fine. That's cubic inches. Then let's do the box, which is length, width, and height. So 15, 12, and 5. No pi this time. That's 900. So the answer to this question, is it yes or no? Will the contents of the can fit in the box? The answer is no. The can is greater than the box. The can is 942. The box is 900, so the answer is no. It would not fit. That would overflow. I like that question too.